Boolean operations are used to create a new shape based on existing ones. There are two main Boolean operations available directly in Blender. One is in the Face menu under the entry Intersect Boolean, and the other is the Boolean modifier. Before we look at these, we should perhaps understand the basic operations that a Boolean command can perform on a shape. To keep things simple, we'll use two overlapping circles, labeled here as A and B. The simplest Boolean operation is union, which creates a single shape by combining the two existing ones. The second operation is intersection. Here, the new shape is the area of overlap of the original shapes, and the final operation is different. This time, we end up with one of the original shapes with the overlap area removed. It's only this third operation where we have to specify which of the two objects, A or B, that we want the overlap to be removed from. Now that we have the basic idea behind Boolean operations, all we have to do is get our head round doing the same thing in 3 dimensions instead of 2. We'll start with the Face menu's Intersect Boolean. Using this command, we need the two shapes to be part of the same object. So, starting with a cube, we'll go to Edit mode and add a cylinder. Next, we'll move the cylinder along the x-axis so that it partially overlaps the cube. After that, we'll resize it. With everything in place, we're ready to execute the Intersect Boolean command. This causes the selected elements to cut into the unselected ones. Here, it's the cylinder cutting into the cube. At the same time, the selected elements are deleted. In the last op panel, Boolean operation allows us to select which of the 3 Boolean operations we want to use: intersection, union, or difference, with difference being the default, since it's the one that is used most often. Swap is only relevant if we're using difference, since it makes the cut in the selected shape rather than the unselected one. Self-intersection can be used if both parts to be used in the Boolean operation are selected. This is not relevant when performing the difference operation. Returning to Solver, it's here we can select the logic Blender uses to perform the Boolean operation. Float is simpler and faster than exact, but cannot cope with more complex situations, as we can see here. When using float, an extra field appears allowing us to merge newly created vertices that are very close to each other. Merge threshold controls how close the vertices have to be before they are merged. Although all the elements involved in the operation must be contained in the same object, we are free to select more than one island when performing the Boolean operation. The second method of performing Boolean operations is to use the Boolean modifier. The advantage here is not only the usual one of all modifiers that the effect can easily be reversed, but also the elements involved do not have to be embedded in the same object. To explain the various options available in this modifier, we'll start with a UV sphere and a cube. Unlike the option in the Face menu, the second object is not deleted when the Boolean modifier is activated, so to make what's happening clearer, we'll change the cube so that it displays in wireframe mode. The next step is to add the Boolean modifier to the sphere. The object to which the modifier is added is known as the base object. Initially, nothing happens, and this is because we need to tell Blender which other object is to interact with the sphere. That is done in the Object field, where we can select from the drop-down list showing all the other objects in the scene, or by choosing the eyedropper and clicking directly over that second object. The object selected here is known as the Cutter object. At the top of the modifier panel are the 3 Boolean operations available to us. Once we've picked the second object and the Boolean operation to be performed, we can also choose the logic used in the Solver area. There are 2 options we've already seen: float and exact. But there's a third option, manifold. This new option is more accurate than float and faster than exact, but it may only work on manifold objects, so any shape with an open edge is likely to fail. We can see this when we try to perform the difference operation on a plane using a cylinder. Each of the solver options have additional parameters listed under the solver options heading. Float has overlap threshold. The value here tells Blender how far apart faces can be, and yet still be treated as if they are in the same position. Watch what happens when we sit the cylinder very close to the surface of the plane and adjust this value. Exact has three further options. Materials has its value set from a drop-down list. Index-based. When we use this option, the new faces created are assigned the material of the base object that have the same index number as the overlapping face of the cutter object. Although that sounds complicated, all it means is that the new faces take on a material that is already assigned to the base object. The second material option is transfer, which transfers the material of the cutter to the new faces. The next exact parameter is self-intersection. We need to check this box only if the base object is a complex shape that loops back on itself, such as a knot in a piece of rope. In the example shown here, the base is an extruded cube that loops back on itself, and a cylinder is the cutter. It's only by selecting self-intersection that we get the correct result. Finally, we have the hole-tolerant checkbox. This may be needed if the base mesh has boundaries. One such shape is Suzanne, because the eyes are actually separate islands, so the eye sockets contain boundary edges. When we try to use a cylinder cutter, we run into inaccuracies if we don't check the hole-tolerant box. The manifold solver has only one solver options, materials, which we've already covered. There's just one final entry in the Boolean modifier panel that we haven't mentioned yet, and that is operand type. Using the default object value, we can only use a single object as the cutter. But the second option in this field is collection. If you recall, collections are how we group objects in the outliner editor. By right-clicking in that area, we obtain a pop-up menu where we can add a new collection to the list. New objects will be added to this collection, and existing objects can be dragged into the new collection. Now, if we change operand type to collection and select collection 2, all the objects in that collection will become cutters.